full. So I'm a full stack developer. I've contributed to Near Protocol. That's the session we had with Web3 clubs back in 2022. Then Polkadot, Ethereum, and Stacknet. Yeah. So today I'll be taking you through the fundamentals of the blockchain, and I hope we shall learn something from it. And I'm audible enough, right? Someone confirm. Okay, awesome. So since we all like to have a good rest, just a moment, I need to, yeah. So let me present my screen and we get started. I think it's up. Yeah. So this is what we are going to go through. It's the fundamentals of the blockchain. Yes, smart contracts and decentralized applications. So that's what the blockchain entails. It entails those two things. Just a moment, let me switch my screens here. I feel like this is not in the right order and it's giving me cursing. Yeah, I think that's clear, right? Okay, yeah. So, yeah, for the past few sessions, there have been talks about the blockchain and Web3 in general. So today we are going to go like another snapshot deeper on how or what the components are. So from the call, we had like an intro call before that had what's going to be covered today, and that is what is digital ownership. So when we talk about the blockchain, digital ownership comes into play. For example, we shall be talking more about tokens, which we shall be interacting with in the coming weeks. We have ownership versus access. So that's the normal software stuff, ownership, access, and we have tokens and digital assets. Yes, we know digital assets is anything starting from PDFs, images, but tokens are a little bit different because they are standardized. And then we have real world Web3 applications. So that was the target for today. So from code on blockchain to products people use. That's the target that we aim at the end of this cohort. For example, from learning how to code on the blockchain to the end of building your own products. So what are the problems smart contracts solve? So we know the old contracts, the way they used to work. For example, I think you have gone through the intro before the blockchain. For example, you meet people, you talk about something, you write something down, and that's it. You work on that paper. So what does the smart contract solve from that perspective? So we have things like charges and fees. Every intermediary extracts value from the transaction. So that's a little bit the high end, what smart contracts work on. Then something else we know is people make mistakes. So the traditional contracts were like, okay, let's write this down. And if everything works according to that paper, then we continue with the contract. But people can make mistakes in a way that somebody wrote a different value, for example, or somebody wrote a different clause in that contract and you signed on it. Smart contracts work a little bit different. That is the exact steps required for a given event to take place. For example, what's required to happen for something else to happen. So people can be corrupted. That's the other thing that smart contracts solve. With a smart contract, it's everything that is predefined, not something that somebody else can decide, okay, we agreed that you're going to be paid 50,000 shillings for this work. But because we have somebody who is a little bit powerful, we can encroach on you and say, nah, we are going to pay you that 1,000 shillings. People are just a single point of failure. One entity controls everything and can fail or disappear. So the old contracts and the old way of doing things, for example, normal backends, that is for software backends, you write everything in your backend, and if something goes down, for example, the AI deletes the database, you are done. So smart contracts solve that because they are not hosted on a single server. They are everywhere. That's what we call nodes on the blockchain. So different nodes make up the blockchain. And of course, maybe somebody has mentioned it. There's only one node required for the blockchain to run. Otherwise, several nodes to make sure that nobody tries to change things or alter things. Uh, what is a smart contract? That's the next question. I have mentioned a bit about it. A smart contract is a program stored on a blockchain that runs automatically when predefined conditions are met. That is, if X happens, then Y executes. This means a blockchain can be set in a way that if 10 people send in signatures, then we release the funds. That's the same logic that we have currently in the banks. Whenever you are setting a company, you have this analogy that you have to set who the signers are in the bank. So you say we are 10 directors, no, 9 directors, then we need at least 4 signatures or 5 signatures for funds to move. And you can set different clauses and say like, okay, 9 directors. For this range of funds, we only need 1 signature. For this, no, at least 2. For this, we needed 2. For this, we needed 3, then 4, etc. So the same with smart contracts. If X happens, then execute. What are the features of smart contracts? They are self-executing. So the moment a smart contract has been deployed on the blockchain, it automatically gets the self-executing feature automatically. For example, whenever you send in a transaction, the smart contract on chain will look at it and execute on the instructions given. They are immutable. So when we talk about immutability, we don't fully mean that the data in the smart contract cannot be mutated. We talk about the actual logic. The actual logic of the smart contract is immutable. For example, once a smart contract has been written that for it to send funds from wallet 1 to wallet 2, or from the smart contract itself to a given wallet, it requires 5 signatures. Somebody else cannot come from the other side and say, okay, I'm going to update this because I want to scam all the other directors and sign only with his wallet. So they cannot change the logic there. That's what we mean by immutability. And the other feature is transparent. Anyone can read the contract's logic directly on chain. So that one is a quick view. For example, we have Etherscan here. So Etherscan is the block explorer for Ethereum ecosystem. So if you come here, let's try to find something like, I don't know whether I can be able to get something like USDC. So USDC is a digital asset, a token. So if I go to contract, I can be able to read the actual logic or the actual contract of this token. So you can learn from it and see how it works. This is what we call by transparency. And I can roll back a bit about transparency. Not all contracts are visible. You have to verify your contract, and that's what is like a standard. Whenever you build your contract, make sure you build it to completion. That is, production level contracts need to be public. So somebody else can come and say, okay, well, I can see this is the logic that you submitted, and it makes sense. We lost our funds through other means, not by somebody changing the contract behind the scenes. So yes, but also something a little bit about immutability. We have upgradable smart contracts. So we don't fully say they are immutable, but sometimes you need an upgradable smart contract. This in the software world, for example, the normal programming, you have to make your backend easily upgradable. That way you can send in fixes. For example, if there's a security issue, you can send in a fix for it. But for upgradability in smart contracts, usually there's a logic to protect who is able to upgrade a given contract. And that's part of the mutability part, like you cannot change who can upgrade a contract. And also that means for you to upgrade it, maybe a number of signatures are required. And yeah, so different people are involved. Yeah, those are the features of a smart contract. Going next, we have how smart contracts execute. Yeah, this direct flow. You write and deploy a smart contract. You get an on-chain address. For example, normal Web2 stuff, we say you get an API endpoint. That's the on-chain address. You send a transaction, post something into the contract, i.e. send funds from the smart contract or from wallet 1 to wallet 2. Then we have node validation. So node validation is where different nodes have to be in consensus and prove that this transaction is legit. Sometimes people can decide, okay, let's pump a given wrong transaction, but that is impossible because blockchains do not run on a single node. They run on several different nodes. So all these different nodes have to be in consensus for that transaction to be executed. Unlike the Web2 stuff where somebody sends a post request into the backend and it immediately executes. That's a little bit different with the blockchain. Why do smart contracts matter? For builders, you build products that operate without a company behind them. So talking about building products without a company behind them. That is like what we mean by the term now decentralization, Web3 in general. The first feature we have said that a blockchain runs on different nodes, meaning anybody can run a node which contributes to the same blockchain. This means nobody can be able to control where the contract is just lying. And that gives builders an opportunity to build products without companies without them, the so-called decentralized applications. But if you have been attending the Web3 Club's Founders Friday and roughly Demo Tuesdays, there are issues coming with that when it comes to legality of everything for that product to work, etc. So yeah, with them you learn how all the Lego impact or the Lego procedures required for you to have like to operate a given product and different kinds of products. The other thing, the logic is open. As I have said, here's the entire logic of USDC contract. It holds lots of funds in it. Lastly, we have composable contracts can call other contracts, enabling ecosystems. This is what happens. For example, this is a token contract for USDC. If I create my own contract for now a Chama, for example, Chiza has built a Chama, not a Chama application, but rather Expendi, an application that allows users safely spend or know how they are spending their crypto. So for that one, he built his own smart contract that interacts with the now, for example, the USDC, USDT contracts on chain. That's what we call a composable. So you can build a contract that interacts with another contract. In the normal Web2 words, we say a backend that interacts with another backend through an API interface or through gRPC or GraphQL, whichever the transport mechanism that you decide to use. Yes, the normal contracts have that one. For users, no platform can change the rules mid-game. That's critical because you don't want that you have bought a number of USDC digital assets, USDC tokens, and then they decide, okay, for you to withdraw, we have decided you can only withdraw up to 5,000 USDC. But banks can. You can deposit up to 5 million, and they say, okay, you can only withdraw up to 1 million. That's very possible. But for smart contracts, that's a good thing for users. No company can freeze your funds or access. Yes, most blockchains are open. Once you can move funds freely, that's why most governments are fighting it back. Like, okay, if you can move funds freely, can we tax these funds? Can we know what the source of the funds is? So there are controversies to that, but that's a later topic. And if we have something else here, participation is permissionless. no approval needed. For you to interact with a given contract, you don't need permission to register a special account for you to do so. For example, if you were to try to start trading on the NSE today, you have to fill a form, wait for you to be approved to join the NSE. I think that's the process, maybe different. Let me give what I know. For example, for FIDA, for FIDA, something that has things with the NSE, you have to create your account, talk to them, they'll get back to you on a later date. For contracts, that's not the case. Real world use cases, we have DeFi protocols, NFT ownership, DAOs, on-chain identity, supply chain verification, automated payouts, and increasingly payments between AI agents. So this is the most new. At the end, we shall see how this happens. But yeah, there are lots of things that you can do with the blockchain. For example, I mentioned something about Expendi. It's an application built on top of the blockchain. Going next, here we have token standards, why they exist. So I've been talking about the digital assets and tokens, right? So what is a digital asset? I did mention a digital asset is anything that's intangible, right? For example, a PDF, it's there, you cannot like physically touch it. Then we have things like images, videos, all those software itself, like the code itself is intangible. A token is also a digital asset, but why is it different? A token is different from other digital assets. Like each digital asset has its own features. So the features of a token. Smart contracts can represent anything, but for tokens to work across wallets, exchanges, and apps, they need to follow a shared interface. So that's the first thing. Token standards are agreed upon rules that define how a token contract behaves. So a token is a digital asset that has a set of rules and a set interface that it operates on. For example, all tokens have same functions. For example, transfer function, read balance function, get the name, getting the symbol. They have the same interface. That's a token. And they have a feature like they are different from normal contracts. For a contract can be anything, your own logic that you want. But for a token, it has to be standard for other users on the same chain to interact with it. And most tokens or most token contracts across different blockchains have the same interface, same functions. Meaning if you are moving from blockchain 1, Ethereum, to blockchain 2, Arbitrum, it's the same interface. So here are the features: interoperability by design. An application that understands the standard can interact with any token that follows it. No custom integration needed. So everything comes together. For example, if you create your own contract today and you want to interact with USDC token, and at the same time interact with the Ethereum Ethers token, maybe USDT DAI, and other tokens, it's the same interface. So you don't have to write custom logic across. Then the power socket analogy, different devices, same plug. Standards make the ecosystem composable and scalable. So this is critical because different tokens serve different utilities. That is, somebody might be having a token specifically for gaming, and somebody has a different token specifically for maybe online payments. For example, stable coins, that's another term for tokens. So a token like USDC is a stable coin because that one is mapped one-to-one with USD currency, meaning you can use to pay anything online. USDC, USDT, DAI, PUSD, there are lots of different stablecoins. So those are the tokens that are pegged one-to-one to the USDC currency. In Tanzania, they are testing out their stablecoin. So the Tanzania, I have forgotten its name. Maybe your chief, you do recall it, you can mention it. So those are different tokens with different utilities. Beyond wallets and exchanges, the devices now include AI agents, transacting autonomously on your behalf. Standards make this possible at scale. Yeah, so those are tokens. Any questions so far?
I have a question, Dalmas.
Yes.
So the one of the major selling points of blockchain is immutability. And earlier on, you had mentioned something about how you can't change the logic. Like you can change something else, but you can't change the logic. So what is it that can be tampered with or changed?
Yeah, good question. So, yeah, immutable in a sense that you cannot change the logic, mutable in a sense that the data can be changed. Usually, sometimes it becomes confusing between the smart contract itself and the data itself. Data changes, but the logic behind it doesn't. For example, how can I give it? So let's talk of a backend with a normal backend. So with normal backends in Web2, you can decide what this function does. For example, if a user signs up, then we send an email to that user welcoming them, right? You can do the same with the blockchain. For example, if 3 signatures happen, then send funds to this specific wallet. Now, what's different between the two? With the Web2, you can go back to the function and say, okay, besides sending the email, the welcome email to the user, go back and uh, add another logic to send another email, maybe to the admin or log, and say there was a new user who signed up into the platform. So with Web3, with smart contracts, you cannot change the logic. If it's 3 signatures to send funds to this user, that's it. What's immutable in the blockchains? The data itself. So some smart contracts can be written in that you can change. For example, somebody was building, this is another real world example, uh, a fantasy application on the blockchain. For example, if 10 players 10 different managers on PL can come together and uh, join a group and contribute some funds, for example, 5 USDC, and whoever comes the top wins. So that's an open object. For example, this is a running league or a running week. So later on, you can write a logic specifically to update this specific league and say it has been closed or it's still active. You see, that's different. But let's go ahead and talk about tokens a little bit. So what about tokens? What we have talked about this contract here. So this is a USDC token contract.
Just a
Yes.
second, Dalmus, before. So clarification. So Ashuka, immutability. If you have a record, let's say I have a record reading that I've got 1,000, or let me say 100 USDC or 1,000 USDC somewhere, right? So that record is immutable. That's never going to change. What I can do is I can update that record, right? And say that now I have withdrawn 100, right? And now I've got maybe, I don't know, 9,900 or whatever, right? So now this new record that has been updated is also immutable. So we can update that, but the question I have is, the fact that we can update, I guess, our logical record, right? Is how can this be used to introduce our vulnerabilities in smart contracts and bad actors essentially?
If come up again, if you can update the logic in the contract.
Like updatable smart contracts, like we can update smart contracts, right? And then let's say the smart contracts is very secure, but we have new features we need to introduce, and we have new logic. How do you prevent bad actors from exploiting that?
Yeah, that's a good question.
Vulnerabilities.
Yeah. So if you have an upgradable contract, make sure. So there are a few things that you need to make sure they are done before you even deploy the contract. Number one, who can access that upgradable function? That is to avoid anybody upgrading the contract. The other one, what's required to upgrade a given contract? It could be you need to have clear logic to make sure an upgradable contract is secure. By the virtue that it's upgradable, it means somebody can alter everything. So for example, in this case, they have illustrated here for this function to go ahead and run, it needs an admin. So this is like a check that's needs, I think we have an admin, this of proxy contract. Okay, that's a different topic of another day. But yeah, so making sure who is calling that specific function to upgrade, like this one here, that's the thing. Assert or make sure that this user is an admin. That's the entire logic. What are the dangers of upgradable contracts? If I go back a bit, I think Polygon had an issue with their USDC token contract, in that somebody was able to bypass the security application. I don't know whether they upgraded the contract or did something. In short, they went beyond they just bypassed the security they had, and then they minted lots of tokens. So what that does is that it dilutes the token itself, and the token loses value. There was a fallback for that. What blockchain usually do is forking. So talking about immutability, when Ochi did add something, they say that you cannot edit a record. Yes, you cannot edit a given transfer or a given transaction. So what happens is, for me to get the current value of a given, for example, token, you need to get the value from the previous block. It's like the block before holds the information about what happened to my balance. That's the thing. You cannot edit that given block, meaning you can reproduce anything, or you can reproduce, for example, the balance of a given address for a given token. That's another part of it. There's a whole lot into it, but yeah. So what happens in case there's a, for example, a breach, is they fork the contract. No, they fork the blockchain at a given block and sort of roll back. There's lots of stories into it. For example, that's where things like chain reorganization come into play. That's how can we recover, or how can we secure other users on the ecosystem. So they have to fork and move on to a different path from the original path, to avoid this, to clear and to close and clear this vulnerability and proceed. There are a number of chains which have done so. Yeah, you can go ahead and take a quick Google. It can guide you through on forking of blockchains and why they happen. When there is a very bad vulnerability in the blockchain, they have to fork, update the systems, and continue operations.
Dalmus, just a second. So for those who are not familiar with these terms, forking a blockchain is like, you know how a fork can like go this way. So let's say you have a chain like base or whatever, and let's say they want to introduce a major update that changes things. So you know how they say you can have a fork on the road, and then you take a different path. So a chain might now take a different path and implement new protocols, new rules, new standards. So that's what forking means. A USDC token, a USDC is a crypto token, or basically a token that is pegged to the dollar. So it is almost like a dollar, but it's like a digital dollar. So it's got the same value as the dollar. And that's what USDC is. There's different ones. There's USDC is from a company called Circle. There's one called USDT, which is from a company called Tether. And so so that's what those are. But we will get into those a bit later in the program.
Yeah. So going forward, we have ERC20 viewable tokens, And this is another term we have introduced here, fungible token, fungible. Okay, we shall learn more about it. So these are standard for interchangeable tokens. Every unit is identical and equal in value. ERC20 defines common set of functions every compliant contract must have. So when we talk about a compliant contract, we talk of a compliant token contract. So at least all these ERC20 that we have talked about, USDC, USDT, DAI, etc., they have, for example, core functions. They have to have similar core functions. They check balance, transfer tokens, and allow others to spend on your behalf. So those are core functions. And these are the examples. I think I've been mentioning them. And why does this matter? A wallet built on for ERC20 handles an ERC20 token. An AI agent that understands ERC20 can transact with any compliant token, no human in the loop required. So this is the importance of having the same interface as we talked about the interface before here. So those are the features of tokens. Going forward, we have other different tokens called non-fungible tokens. Non-fungible tokens, I can just give an example of what they are. For example, sometime back we had people buying sort of artwork or images, the so-called NFTs. If you were active on Twitter, maybe it might have come across your timeline, but well, if you're not into blockchain and crypto, it never came. So non-fungible tokens are a little bit different. Instead of them having same and identical unit, for example, with the tokens, each token is the same value. For example, one USDC equals one USDC, of course. But when we talk of non-fungible tokens, these are a little bit different. We talk of, I like referencing them, things like images. That's the simplest term I can give them. So these ones are a little bit different, and they present a different analogy of tokens. What makes it different? What makes non-fungible tokens different from ERC20 tokens? Every token has a distinct ID and is not interchangeable with another. So that's the first thing. For example, if you have a token ID number 1, it's not the same as token ID number 2. Why? Each token has a different value. Ownership is tracked per token, not per balance. So unlike ERC20 where you track like how much USDC do you have? I have 5 USDC. For these ones, you can have different tokens. You cannot just call balance on them. You don't own 10 units, you own token number. So this like, let's give this a good example. It's like units in a flat, in a building. So each user has their own like room or their own space. That's what ERC20, ERC721s are. I'm trying to get a good example for them.
Yeah, that's an exciting idea. Let me help you. So fungibility refers to, it is a property of things that makes, that distinguishes is something unique or not. So for example, and this non-fungible tokens, this is now what NFTs was. If you guys only know it as NFTs, that's what it stands for, non-fungible tokens. So let me give you an example of something that is non-fungible, right? That is completely distinct. If I create a painting right now with a brush, that painting is non-fungible, right? There is no other painting like it, and there's no way of me swapping that painting for another painting that is identical. It's just not possible, right? So, and that's where now the value comes from, right? So it is a digital representation of non-fungibility. So let me give an example. If I have a painting like Mona Lisa and I put that on the blockchain somehow, there cannot be multiple copies of that, right? And so that means that that token is non-fungible, or that piece of art, digital art, is non-fungible. Now, a fungible token of fungibility then now refers to how you can maybe exchange two different items that have the same value. So for example, if I have a Kenyan 100 shillings note, yeah, and you have another Kenyan 100 shilling note, if we exchange that, there's no difference. My note and your note is the same. Like these are two different objects, but they fundamentally represent the exact same thing. No one, like no one will say no to your 100 and yes to mine. Like they're exactly the same thing. So now these ERC standards are representing that on a digital level. So if you have a non-fungible token, then that means that there's only one of its kind in the entire world. In its digital representation, that there is no other, copy of the same. So that's what that is.
Which I
Yes.
have a question. So it means you can have many owners, right? The token is one, but I need to have many owners. Like, can different people own a piece of the Mona Lisa NFT, or yeah. Can that happen?
Exactly.
And will those people individually have that token? Yeah, okay.
Exactly. So this is now why blockchain is very, very exciting and why I believe it's not going anywhere. It can slow down, it can go through a bear market, bull market, but it's not going anywhere. So now you've got this non-fungible token, let's say this piece of art or a song or something, right? That is a unique copy on its own. So that in itself is an asset class, right? So what you're asking is, can multiple users or even agents take part in ownership of this one non-fungible token? And the answer is yes. So now this brings up the idea of something called fractional ownership. If the value of this token is, let's say, $1,000, right? And then they set it up somehow that people can buy shares of this piece of art or this token, just how you have like shares of Safaricom, whatever. So let's say this thing is worth 1,000 and I put it on the market and I say, I'm breaking this thing, the value of this thing into $0.5 per share or like you can buy $1.5 per share. And that means we will now have essentially like 2,000 shares that are floating at $0.5. And then if I have $100, I can buy $100 worth, right? Which means I can buy 200 of these tokens, and then I have that much ownership of that. And if you only have, let's say, five, then you buy that five, and we can all pull together until we consume that order. And now we all own this thing digitally. And if this thing now gets sold somehow, let's say it was going for 2K, that was the value, and we now start selling our shares maybe or maybe the demand for this goes up and we're now selling it at 0.7, then we are now essentially making profits on the sale of this just by owning a portion of it. So the answer is yes.
Okay. Awesome. Thanks for that, Ochi and Ashuka. Any questions about the same? Yeah. So examples have been given. So digital art, the Mona Lisa, any collectible, event tickets, proof of completion certificates. So, for example, a certificate, yeah, you cannot go and split it or create an. That's to you, but it's good to have like a digital identity saying that you did finish school at this and this is what you got. So, for example, in some cohorts, you might be getting proof of completion certificates offered. Then we have why does this matter for builders? Any unique asset, land ownership, a membership, a credential can be represented and transferred on chain without a central registry. So that's one of the features that, yeah, if well executed, someone can use the blockchain to do this. For example, you transfer ownership of land, you get paid, and well, you do not need like a digital registry to or a centralized registry to track everything. An AI agent can be issued an NFT as a verifiable credential, proving what it's authorized to access or do. Yeah. So this is one application of NFTs. The other one is for you to get some access to some let me say, programs of the blockchain, sometimes you will need to buy an NFT earlier on for you to get access. This is like a program like Aether, in which if you wanted to be an investor or a contributor to that project, you had to buy an NFT, and that NFT will say and show that you are part of the members of this. So it's like, yeah, the digital identity that is visible and one can prove. Going forward, we have introducing X42, payments for agentic web. So we had this, the 42 status code in the Web2, and that has been there for some time, not now. But now with the blockchain and AI agents, in which you require to make some payments for you to do some stuff. So that's what's called X402. So this is more of a new protocol introduced into the blockchain, in which you can make payments on request. You don't have to make payments before. You just get a request, make payment, and continue to get the feedback back. So as AI agents become more capable, they need to pay all for APIs, data, services, and compute autonomously without a human approving each transaction. X42 is an open protocol built on HTTP that enables machine-to-machine payments, reviving the unused HTTP 42 payment required status code with a real stablecoin implementation. So yeah, this is a good one for the current state, where if you are building an AI agent and you want this agent to talk to another agent that has a given resource, this includes things like selling of data. If you can implement something around that part, for somebody to be able to access data in your system, they need to make a payment, for example, to access maybe PDFs. Yes, for cargo, you can just hit cargo, download the data sets, and do whatever you want with them. But now with this protocol, you can now make your data like somebody can pay for it. I'm not going to go to the depth of X42, but just know it's a way for agents or for dApps. You can just enable this in your dApp. That's a decentralized application for somebody to make payment on request instead of like long-running subscriptions. So here we are going to have a quick demo. That is how smart contracts work. So this one will be a short one, not a very long. So we have the USDC contract here that I showed earlier. And for this one, I need to go back. Okay, here. If I go to read as proxy, so different ways of doing this.
Dalmus,
Yes.
can you explain what this is? What is Etherscan? What are we looking at? Yeah.
Sure. So Etherscan is a block explorer for Ethereum, and each blockchain has their own explorer. What Etherscan allows one to do is, for example, track transactions, and they have indexed the blockchain, the Ethereum blockchain. If I go back to the blockchain itself, we were talking about the blockchain and the nodes. So there are different nodes that make up the blockchain, and that information on its own is less information, like very small information, if I may use that term. So what Etherscan does is indexing the blockchain. This means is taking those different transactions with the different unusable data and organizing it in a way that somebody can use it. For example, in a way that you can, see, these funds moved from this wallet to this wallet. One feature of the blockchain is the ability to reproduce the information. For example, if you want to know the balance of a given address now, you can recompute that by visiting the transactions before. So that's I'm trying to recall the term for state machine. Yeah, it's a state machine. The blockchain is a state machine. So you can reproduce anything by computing the value before that, for example, that period. So Etherscan has indexed that for you already, in that now you can, see some data. If I go back to the landing page, this has been indexed, and you can see the different transactions that have been happening on the blockchain. If I click on view all transactions, you can see the different transactions where they have said they moved, like somebody moved the funds from Paxos to some PayPal, whichever, or a swap happened. We have things like NFTs, top NFTs. If you were to just open the node itself, you wouldn't find this information just there sitting. So that's what Etherscan does. Take the data from the blockchain, index it to something that somebody can now use. You won't find like this information there. The blockchain itself is very, very small, like the data in the blockchain. For Ethereum, it might be about 600 GB, but the indexed data itself is about 20 terabytes. Okay, I might have missed the numbers, but yeah, the blockchain itself is small, like the data in the blockchain in the nodes, but the data that is being indexed can be 100x of the actual value of the blockchain. So Etherscan helps in indexing that information. I'm going to go back. So these are different types, different data indexed on Ethereum. So we have NFTs, we have other data here, like the latest trades, latest transfers. We have contracts. So I'm going to show you another Explorer because I'm more inclined into it. So we have Stacknet. This is Voyager for Stacknet. If you look at its data also here, we have like top contracts, the protocols. Protocols in this case can be something like Uniswap, Avenue, etc. We have tokens, active users, like active contracts, etc. So these are like explorers. They have just indexed the blockchain to give you like something that you can make sense of. Going back here, yeah. So that's what we are going to explore, a quick one. And here we are going to interact with the USDC contract. I'm trying to find the contract. Yeah. So if you come to this page, you will see the holders of that token, the transfers that have been made. These are like the total transactions, info, DEX trades. Yeah, my screen is frozen, or I'm limited by Cloudflare. Okay, yeah, there we go. So this is the information that you can get after indexing. Who owns what, by what percentage. So you can look at the different transfers that happen here in real time. Then we have the information about the contract or the token itself. Then DEX trades, this means different trades on different DEX, different decentralized exchanges. A decentralized exchange is different from a centralized exchange. Uh, a decentralized exchange only allows you to trade or transfer value, swap value between two tokens that you own, or a token that you own to a token that you don't own. For example, you have USDC and you want a Lords token for you to go and play the Lords game. So you can swap USDC to the Lords token and go play the Lords token if you are going to make any payments there. That's decentralized. Centralized exchanges means that you can swap your fiat, for example. That's one of the features. It's not a must feature, but that's one of the features that make it centralized. You can swap fiat. You have funds in your M-Pesa, in your credit card. You can buy USDC on a centralized exchange, for example, Binance. I'm going to, so let me just show you Uniswap. This is one of the real world examples of a decentralized application. So here I can swap, for example, from USDC to whichever. Just a moment, let me find a proper token. So for example, from USDC on Ethereum to DAI on Ethereum. So these tokens have the same, like sort of same value because they are stable coins pegged one-to-one to the USD currency. So this, I can swap what I have to what I don't have just within the blockchain. But if I have cash and I want to swap it for USDC, then you need a way of buying them. That's why we have things like off-ramps and on-ramps. So we have Rift payment, for example. We have Yeah, that's from Kenya, or you can use Binance.
Yeah, Pretium.
Yeah, we have Pretium to on-ramp your fiat to crypto. Once you have crypto, now you can swap to any chain, to any token. Yeah, going back to our target here is to interact with the contract. That is the USDC contract. For now, I'm going to just go to read as proxy. This is a proxy contract. A proxy contract is different from a normal contract. Let me give a quick explanation. A proxy contract is like a bridge to the main contract. Talk of this like a Nginx reverse proxy for your API. Your API runs locally on your server, but for somebody to access that one, they'll need a way of accessing that one. So you can implement Nginx over your API, and anybody can access the API now globally. So they work the same. It's the same story behind. So for this one, there are different functions here. But besides that, we have this specific function here called balance off. So balance off is one of the standards that any token contract must implement. So we have balance off transfer from, allow, and and no, something like increase, pending, decrease. But there are those specific functions that a contract has to have, and the balance of is one of them. And for this case, I'm going to get a wallet address. So I'm going to paste it here. So what's a wallet address? A wallet address is like now the identifier that you get when you have your own wallet. Wallets are different kinds of wallets. We have custodial wallets and non-custodial wallets, a story for another day. For this case, this is a non-custodial wallet. So I'm going to query using my address. And here you can see I have 0 balance. But it's because I have no funds on this wallet specific for this contract. This is a read function where I was trying to get the balance of this specific wallet address. We have write functions. Write functions include a function to transfer funds from one wallet to another wallet. I don't have a specific direct example I can use here, but let's see. I'm going to show you an example on Voyager. No, on Stacknet, not on Voyager, on Stacknet. So I will pull this one here, expand, and then.
So Stacknet is another blockchain on Ethereum, and Voyager is a block scanner. So yeah. For the technical terms, Mr. Zali, we're going to cover them later.
So let's see how we interact. So the one that we had here was Etherscan. For this one, I'm going to show you Voyager. So it's the same logic behind. So like how to interact with a contract. So here I'm going to see something. Let me make sure I'm in the right network. I have like a 1.4 stack. And for example, I need to get myself like maybe some ETH. So what you do is to interact with a given contract. And in this case, I'm going to interact with the Avenue contract to swap from stack to ETH. So I select my token here. I select the receiving token. I say want to swap one stack to some ETH. So it's going to calculate and show me how much ETH I'm going to receive. So this is what we call interacting with a given contract. It's either you are reading or like now trying to make a transaction. So what has happened here, this is a transaction, and you can, of course, check it on the Explorer here. So this transaction has happened and it has been indexed by the Explorer. I don't think if it's fully indexed, not yet fully indexed, but yeah, it will be indexed in just maybe a few seconds. But yeah, it will show what has happened in that specific interaction. For example, here, I only did a single swap here from stack to ETH, but what happened behind the scenes is a whole lot of things that we shall learn along the way. For example, what happened for me to receive ETH in my wallet. So a lot of things went into it. For example, there was a transfer of the StackGate token itself for me to pay the gas fee. There was another transfer through the Avenue exchange, a transfer, lots of transfers along the way. This is what makes up a decentralized exchange. It means it will find the best route for you to receive the most value for your swap. For example, one stack can give you, for example, in this case, 0.002 ETH, and at the same time, it will give you 0.001 ETH. It depends on the route that you took. That's a whole lot story about decentralized exchanges. But yeah, so that's the basic interaction. There's a contract somewhere, and if you are interacting with it, you don't have to have permission or any special sign up for you to interact with that specific contract. I'm looking for my, yeah, that's it. Oh, okay, something else. Before I close this off, we have something called dApps. dApps are decentralized exchanges. For example, what I showed you here, Uniswap, is a dApp. It's a decentralized exchange. For it to run, it does not need its own server, meaning it's utilizing the blockchain technology to fully run, meaning nobody can just come and say, okay, I'm going to shut down this thing and then move on with life. That's impossible when it comes to decentralized applications, because the application server itself, the backend or the logic itself, does not run on a single server. ICANN can shut down a given domain. For example, it can decide to shut down Uniswap, but the Uniswap contracts will still run, meaning if I go to Etherscan, I can interact with the Uniswap contracts and the swap funds the way I want. So so dApp architecture, let me show you the bigger picture of it. So a decentralized application has three core layers working together with an emerging fourth layer reshaping how users interact with everything. So we have a front end. So this is the front end that we see here. Then we have a smart contract. So the Uniswap smart contracts themselves that you can directly interact with on Etherscan. And then we have the connection layer. So the connection layer, this is like the required libraries required to make the front end active. Like how can it interact with the smart contract? So for Ethereum, we have Ethers.js as a good SDK that you can use to interact with the smart contract. WAGMI and wallet providers. Wallet providers involve things like, of course, MetaMask. WAGMI is a library that we do use. And then we have a new layer, the agent layer. It sits between the user and the dApp, interacts with the contract directly, makes decisions, pays via X402. So that's the new upcoming layer. So autonomous agents can help you, like, for example, do trading on Ethereum. So trading on Ethereum involves things like perpetuals, swapping, and doing degening. Yeah, let me leave it at that. Next, what this means for what you are building. So for the current cohort, what does it mean for what we have covered so far about X42? So for the founders track, the next wave of Web3 products won't just serve human users. With X42, your smart contract becomes a monetizable service endpoint. An AI agent can discover it, pay for it, and use it all without a sales call or a subscription form. So that's the flow. Like now we can move from just having smart contracts that are just sitting there, but smart contracts as services. For builders track, you are not just learning to write contracts for users, you are learning to write infrastructure for agents. The contracts you deploy could be the backend of an autonomous AI economy. This means you can build a smart contract and a DApp, of course, where agents can interact with it safely. So there are some kinds of smart contracts. Smart contracts like a trading smart contract, where they execute on changes of the blockchain, for example, listening and looking at the mempools, etc. So yeah, AI agents can help in that. Yeah, and if you have any payment requirements, then AI agents can make the payments using the X42 protocol. So what we have covered so far, we have covered smart contracts, contract execution, ERC20 versus ERC721, the DApp architecture, and X402. Any questions so far? So I think then we go to the discussion questions. So the question is, are we still building for humans or for agents that serve humans? With if AI agents can discover services, negotiate access, and pay for them autonomously using X42, what does that mean for how we design products? Yeah, this is the discussion question we have today. And I think from here we need to break out. Ochi.
Let me handle that case. 1 second.
Yeah, so we shall go to breakout rooms and we discuss around this. Yes, it's new terminology, but the question is, are we building for AI agents? We all know AI agents and how they work, and maybe we are using them, at least I believe. So for those who do use AI agents for coding purposes, for maybe writing purposes, what do you think are we building for? Is it humans or just AI agents that serve, of course, humans? So that's the discussion question.
Can guys start discussing now, as the pressure is on me right now to create this.
Okay, sure. Yeah, anybody, you can just unmute and give your view. It doesn't have to be, yeah, we are all learning, so just give your view on this topic here.
Dalmus, you can call a random name, wherever the
Okay,
spirit guides.
sure. Shadrach, that's for you. I think you can see my screen still. So for now, just give a comment, and then Washuka, you don't have to worry about the breakout rooms. This will be left as a
Okay.
as an assignment. But yeah, if you have a comment for this, kindly, before Washuka closes it off, you can say something about this topic. Yeah, I think I can start to give an opening. Yeah, are we still building for humans or for agents that serve humans? So randomly back in 2000, whichever the .com bubble was, they said everything is going to die about domains and everything. Yeah, it's because the investors were investing in the wrong place, right? But now AI is here, and we have the same level of not knowing what's going to happen with this entire fiasco of AI agents. So my take for this topic is like, yeah, we are building for both humans, because if we look at the use of AI agents, it has not been widely adopted so far. That's the thing. Like, banks can't really say we are going to allow an AI agent decide whether this transaction was completely fraudulent or not. Though it's being used there, agents are being used there to check for fraudulent activities, but at the same time, not like autonomously. So we are still building for humans. That's that's my take. Uh, till AI agents become stable, then yeah, we will be building for agents that serve humans still. But yeah, so one thing I can add on top here is, let's say the current flow of paying for doing shopping online. Let's say you are doing shopping on Jumia. Usually you take your time to go to Jumia site, uh, search for what you want, and you get maybe the seller with the highest reviews, the seller with the best reviews, and then you buy from that specific seller. So yes, we can give an AI agent the autonomy to do that. For example, if I want to buy something like, how is it called? Let's say I want to buy a storage box for my data, right? So instead of me going and looking for a way of trying to find a storage box by me, I can allow the agent to go to Jumia, find the storage box, and then using the X42 payment protocol, it can pay for it and only wait for the shipment to arrive at me, to my place. So at the end, it's like, yes, we are building for humans directly, and at the same time, indirectly through agents. As agents as a layer, as a bridge to do the heavy lifting work. For example, searching for that storage box can take somebody who is into it a good time, maybe that minutes. But if you give that to an agent, maybe 5 minutes, it has compared, sorted, and gotten the best value. And yeah, so anybody else? Shadrach decided to mute. We have
Patrick has something.
yes, Patrick.
Patrick has a comment in the, I don't know if you can unmute, but he's pasted his question.
Okay, I will say both. On one hand, the AI agents could take advantage of the cheap repetitive transactions for a specific use case and purpose. On the other hand, humans have been using blockchains for payments and trading. Sure. Yeah, that's true. Nice comment, Patrick. Anybody else?
Hi, I would like to my contribution.
Yes.
Yes, we are building for humans and for agents that serve humans as well, because so far AI is still not that stable. It's still under development. And for my case, I'm in digital marketing. So when we talk about AI agents, they have specific answer to what you have in the website. For instance, you're a customer, you want to buy one of our items. So the AI agent responds very fast. It greets you and say, "Hi, Dalmus, how can I help you?" You say, "I want this and this particular item." It even gives you the price of the item. But there comes a case whereby we have different price list. You now want this item in wholesale price because you are going to resell it, unlike somebody else who wants the item for home use. So the AI still can't assist you in that. You will still be referred to a human being for a system. So for assistance, sorry. So even as we are building for humans and for AI agents. That is my take, because both human input is required and AI assistance is also required for fast response, and efficiency mostly mostly relies on human beings. So we are building for both. Thank you. That's my take.
Nice. Thanks. That's a good one. Yeah.
Yeah,
The
and
good explanation.
that is a very important pinpoint that Charlotte has brought up, because I remember the other time I was trying to dispute an order on Bolt food, because I had ordered food and then they keep bringing missing pieces. Was it mchele bila stew? And then so I'm there in the customer service and they bring their agent and I try to explain the situation. At the end of the day, I abandoned everything. So
Yeah.
yeah, we are still not there, but what a beautiful world if we got to that level. Yeah.
Yeah. So including X42. So with X42, the human will immediately notice that they are missing. Yeah, there are a few proofs or some papers some people are doing. I don't know whether they are being done by humans or other agents, but yeah, they do say that AI does not have a memory. Yeah, sure, it doesn't, because you have to give a memory to it every time you are doing some task. But with the time, maybe a solution will be up and running. But for now, yeah, we are back building for humans. Any other comment?
I think Gabriel has something.
Yes,
Hi
Gabriel.
everyone,
Hi.
I'm Gabriel Nyamu. What about this question? I believe that we are building agents that serve humans. For example, let's just look at supermarkets, for example. When you are buying things from online supermarkets, like let's say the online quick mart shop, you won't you'll make suggestions based on what is there. You'll buy things based on what is there, right? Now imagine that whole situation being automated by an agent, right? So basically the agent is being made to serve a human. And for that case, I am the human and the agent is going to automate that whole process from putting things into the cart and being automated up to like reaching to my gate or to my front door. That's what I think.
Sure. It's a good perspective. You give it the context, it will do the cut and everything, and you just, yeah, sure. That's a good perspective, Gabriel. Anybody else?
Yeah, Carol, I think, and then Ashley.
Hello, everyone.
Hello.
So I think we are doing both, but it actually usually say that it depends with the case scenario. For example, can we say like Maltbook is actually an agent that serves human beings because it's a social media for AI agents and it was built for AI. So I usually, in this discussion, I can approach it in a way that it depends on the case scenario on what we are actually aiming to achieve. Because if you're to get to understand what the founders of Multibook wanted, they envisioned like a world whereby people could have their own AI agents, which could get to understand each other also and have their own kind of world over there. So as much as we're also building for agents that serve human, but I think also there's a possibility that we're also building just for agents to get to understand themselves, each other. Yeah.
Yeah. So that's a good contribution, Carol. Yeah. So that's a good angle. Multiple agents for agents, but still, they're agents for humans. So, yeah. And so Ashley had something to say.
I want to contribute towards how we decide, I mean, how we design our products with AI agents. So, I had a conversation with someone, and they were like, we're gonna have a machine economy, something like machine GDP. And they were like, with AI agents, for them to find services, negotiate, access, and pay for them, they're gonna be looking for the cheapest and the smartest route for them to achieve that. So whenever you're deciding your product, and uh, you have to make sure that your product will be the cheapest and the smartest route option. So yeah.
Okay, a good one. So agents can easily tell from the options they have: cheap, a good one, like better features, etc., and then decide on that. Thanks, Ashley. Anybody else?
Yeah, I have something. So of course we're doing both, but I think building agents that serve humans is the most efficient way. In the long run. Maybe not now, but in the long run. So like right now, I'm a human being. I need services, right? So let's say maybe I'm planning on going to school, maybe to do my master's in the next year. Maybe I need to buy stuff, I need to make investments, I need to do many things, right? Now, by myself, I am not necessarily in a position to number one, have access to all the information that is available or relevant, right? Like it's there on the internet on Google, but I as a human being cannot like enter the internet, and pass through all the data, right? An agent can do that. An agent can, number one, an agent has context as to who I am. So they know this is Achille, he loves this sports, he's interested in this field, this is what his life looks like, and this is what he's trying to achieve, right? If an agent has that knowledge, right, then this agent could essentially serve me in the most efficient and effective way. It can summarize for me the schools that are a good fit, that are within my budget. Let me know which is the best time to apply based on even what I'm doing now. Like it has all this context and it can do that. So I think that's where everything is going, honestly. And I think it's a very positive thing. There's very many ways of abusing it. But yeah, ultimately the edge is to be there, not to be left behind. Yeah.
Nice. Yeah, it's agents that serve humans, but with of course the right security considerations into the agent itself, it means it will be pretty secure to avoid the thing that just happened on Instagram the other day. So yeah, it's agents that serve humans, but you have to be keen on the
What happened on
implementation.
Instagram?
So the Instagram chatbot, somebody just prompted it to change a password for a given user. They gave the agent the email to send the token to. It did send the reset password token there. In short, they took over somebody's account just using the agent itself. So that's how agents that serve humans, or how integrating agents to the current workflows is a little bit delicate. But with the right implementation, some agents do work very well, very well. Yeah. So if there are no further questions, I'll roll it back to Ochi and Washuka. Yeah, that's it from me.
Yay, Dalmas, thank you so much for that. Reviews are already trickling in. Charlotte said they really enjoyed today's class and the content is flowing. So thank you so much for that. I feel like you've also sort of wrapped together what we've been trying to understand from Tuesday. So this was a really interesting session. I want to thank you for your time, and announcement, tomorrow is Founders Friday. So whoever is around Ngong Road, Applewood Adams, just opposite Greenhouse is the Web3 Club's location. We're gonna have founder presentation from, is it Timon, right? Yeah, from Timon. Yeah.
We have two
Can you give more
speakers.
context on that?
Yeah, so as you guys know, Founders Friday is our founder support program. So basically, we get experts and people who have a lot of experience to share insights on starting businesses, startups. So yeah, so one of the founders of a wallet called Timon, who will be here tomorrow, and they will be talking about monetization for startups. So that will be happening at 4 p.m. And at 2:30 p.m. we have a special guest from America. He's going to share some few words with us. Yeah, that will be happening at 2:30. So 2 sessions tomorrow, physical. The lab, for those who are in Nairobi, feel free to pull up. Ask for details in the group. Yeah, I think that's it for today's session. We had a breakout session plan, but I think we can do that next time.
Yeah. So hope to see you tomorrow, as many of you as possible. And thank you for, if you're still here, week 1 today, you're already part of us. Officially welcome to Web3 Clubs. Even if you try leaving, you will come back. I'm just telling you in advance. You're already in too deep. Welcome to the blockchain and AI space. Yay. Oh, I don't have mine today. Yeah, so you've been a very nice audience. Let's see each other next week on Monday. As I mentioned, I will share the program again. But yeah, thank you so much and have a lovely night.
Na wale hatujaona kwa kamera,
Anything?
Mungu ameona. Mkange tu mkijua hivyo.
Bye.
So cheers. Have a good night, everyone. Bye.
Bye.
All right.